Hello and welcome to our YouTube channel. Today we are going to solve question number 26. And question number 26 says we should solve the differential equation dy over dx plus 4x over s squared plus 1 times y equals 1 over parenthesis open s squared plus 1 it closes all cubed. The first thing to do to solve this differential equation is to identify this type of differential equation. This is a first order linear differential equation. And to solve any first order linear differential equation, we have to find something called an integrating factor. The integrating factor is going to make one side of the differential equation to be an exact differential, and you could go right ahead and integrate. So let's find the integrating factor. IF integrating factor is e raised to the power of the integral of the coefficient of the dependent variable, which is 4x, all divided by s squared plus 1 dx. If we do this, we have e to the power of the integral. Now this 4 can be written as 2 and then 2x over s squared plus 1 dx. We know that by differentiating x squared plus 1, we are going to have 2x dx. So this is derivative of function. So this entire thing is e to the power of 2 the ln of x squared plus 1. Send this 2 as a power of the ln. So we will have e raised to the power of the ln of x squared plus 1 all square. E raised to the power of ln of anything is just that thing. So the integrating factor is equals to just x squared plus 1 all square. X squared plus 1 all square. Once we find the integrating factor, we will go right ahead and multiply the entire differential equation by this integrating factor. So this time this is s squared plus 1 all square dy by dx plus, now if we multiply this by this, one of this, because this and this are the same, so one of these will go here and we just have x squared plus 1. So this is 4x parenthesis will be x squared plus 1 times y equal, so you have 1 over x squared plus 1. Once we multiply by the appropriate integrating factor, we will realize that the left hand side will always be an exact differential. It will be the derivative of the dependent variable multiplied by the integrating factor. So this side will be d by dx of the dependent variable is y, and the integrating factor is s squared plus 1 all square equals 1 over s squared plus 1. Now, if we apply the product rule here and differentiate this function using the product rule, we are going to get this left hand side. So let's quickly do that. If we keep s squared plus 1 all square constant and differentiate y, we have s squared plus 1 all square dy by dx. Plus, if we keep y constant and differentiate s squared plus 1 all square, multiply the power by the coefficient, and then subtract 1 from the power and multiply by the derivative of y in here. So the derivative of s squared plus 1 is 2x. 2x times this 2 will give us 4x. Then we'll rewrite s squared plus 1. That is it. Once we do that, the next thing to do is to integrate both sides. So we have d by dx of y parenthesis over x squared plus 1 all square dx is equal to 1 over x squared plus 1 dx. So we integrate this side and then we integrate this side. The integral of the derivative of any function is just that function. So it's y times s squared plus 1 all square equals to the integral of 1 over s squared plus 1 is tangent inverse of x plus c. Thank you very much for watching, and we'll see you in our next video.